In this presentation, I talk about parallel sailing formula, which is the foundation of Mercator's projection. And what I mean by parallel sailing is sailing in east-west direction along the parallel of a latitude. As per WGS 84 datum, the Earth is a spheroid with a radius of 6,378,137 meters, which is same as the radius of the equator. And we know that 1 minute of an arc of a great circle on the Earth's surface is 1 nautical mile. With a mean value of 1,852 meters at 45-degree latitude, which can be verified by the formula 2 pi r, the circumference of a circle. Now let's draw two meridians so that one is passing through point A and the other one is passing through point B. We can see the d long along the equator and its arc AB are in minutes. Therefore, they are in nautical miles. And the angle at the center of the Earth between the two meridians, which is lambda, is taken in radians. And this angle is the same angle at the pole between the intersection of two meridians and all the way along the north to south along the axis of the Earth between the planes of two meridians. Now let's draw a parallel of a latitude which has the same d long, the angle lambda. However, it is a small circle and its plane is parallel to its parent circle, the equator. The angle phi at the center of the Earth is the latitude, making an arc FA, and that arc is equal to the arc TB, and their radius is the capital letter R, the radius of the Earth. The angle of latitude phi remains the same at the center of the Earth throughout between the planes of the two circles. The small letter r is the radius of the smaller circle centered at the axis of rotation of the Earth. The length of the arc FT in east-west direction is called the departure in nautical terms, where sailing on the parallel of a latitude phi. Even though it's having the same numerical value of d long lambda, this arc is much smaller than the length of the arc AB, which is on the equator. And the objective of this presentation is calculating the length of the arc FT, which is the departure, in nautical miles. This diagram on the right is showing the same view from a different perspective. We have rotated the globe so that our meridian North Pole FA is showing on the circumference of the Earth, North Pole FA right toward the east. We can see the radius R from C to A is same as R from C to A, and also the radius R from C to F is same as C to F, which is making an angle phi, which is over latitude and the arc FA. And we can also see that the smaller radius r from D to F is same as smaller radius r G to F. And in this configuration or in this construction, we can see that angle of latitude in the center of Earth is the same angle of latitude at the point F. Using the simple formulas learned in grade 10 to 12 calculating the arcs of circles, we can see that the greater arc AB or the d long is equal to the capital letter R, the radius of the Earth, times the angle lambda in radians. And similarly, the length of the smaller arc FT or the departure is equal to the small letter r times the value of lambda in radians. And in the diagram on the right, we can see there is a right angle triangle CFD, in which CF is the radius of the Earth, capital R, and DF is the smaller radius R of the parallel of the latitude phi, and the angle between the capital R and smaller r is the angle phi, which is the latitude. The trigonometric ratio cosine is the ratio between the adjacent side to an angle to its hypotenuse. So the adjacent side to the angle phi is small radius r, and the hypotenuse is capital radius r. So small r divided by capital R is cosine theta. Therefore, small letter r is equal to capital R times cosine theta. Now we can substitute the value of the small letter r, which is equal to capital R times cosine theta, into the expression for the length of the smaller arc ft or departure. Small letter r times lambda becomes capital R times cosine theta times lambda. We can slightly rearrange the value of lambda and capital R and we'll put them together. And we can see that actually capital R times lambda is the arc of d long or AB. Now we can put our expression in the right order. So our departure, which is arc ft, is equal to the d long or the arc AB in nautical miles times the cosine of the phi, and phi is the latitude. So departure is equal to d long in nautical miles times the cos of the latitude. This simple formula was the core concept of Mercator's projection, and we will expand it in the next video to see more complex math of Mercator's projection.